Okay, so for this question, okay, for this question, the let's see, this is a 2008 paper one question. It's quite a old question, okay, but it is quite a good question generally. So what happens is that to solve this question, right, you will need to be able to identify potentials at each node. Okay, this is what we call the nodes, this part, and we will need to calculate the potential, the changes, and then after that, from there, we find the difference in potential between these two nodes. That will be the potential difference. Okay. So generally, what happens is that we can let one of the nodes, let's say we of this, that means that this node will let it be 0 volts. Okay. And here it will be 6 volts because the EMF source will cause a potential difference of 6 volts and will cause an increase, a potential gain. Okay. So for resistors, right, it will cause a potential drop. So you can see that the bottom part here is actually a circuit in its own, which is parallel to the top part. Okay, so in another way, we can see that the 6 volts is actually for the bottom part, it will actually go for R and R. That is the bottom part. Okay, and then the top part you can see is going to be parallel, but instead of going to the top, imagine I'm going to pull this all the way down here. Okay, so now I get a T and then a R. So this is what is happening, and we can put a voltmeter here. This is what this is what the question wants. Okay, the voltmeter wants the potential difference here. Okay, so it doesn't really matter whether you solve it this manner or this manner. They are actually going to be the same. Okay, so let's say we solve it this manner, the original one, before we go to this updated one. Okay, this is the redrawn version. We can also solve with this, but let's say we solve by the original version. Okay, so the resistance of T changes from R to 5R. Now, what happens here is that I have two diagrams here. Okay, I have two diagrams copied out, and I will be writing the voltage. No, sorry, the resistance, and then after that, the potential. Okay, so at the start, T is R, so this one is actually going to be R, and this is actually going to be 5R. So what happens here is that if we let this be 0 volts, this will be 6 volts. In this series circuit here, okay, you can see that there's actually a series circuit here. It goes from here to here. There will be a potential drop of 6 volts by the time it comes here. And because it's R, okay, so what happens is that you have 6 volts, then you have R, and finally 0 volts. That's what is happening here. Center here must be 3 volts. Because so that the potential difference for the first one is 3 volts and then 3 volts. Okay, because of the potential divider rule. So this one will be 3 volts. At the same time, this will be 3 volts. Okay, because this is R. So for the first part, the initial part, our potential difference is going to be 0 volts. Then they change it to 5R. Now, for here, still 0 volts, 6 volts. Here is still 3 volts, nothing special. It's the top part here. So 6 to 0. So you have 6 volts. The top part, you have your 5R, R, and then 0 volts. So what happens here is that the potential difference across this 5R, the potential difference must be 5 volts, which means that our potential is 1 volt. So the 6 volts and the 1 volt, the difference is giving me 5 volt. So here it must be 1 volt. Okay. So with 3 volts here and 1 volt here, we will read 2 volts. Okay, here with a higher potential. So initially 0 volts, final is 2 volts. And the question wants what is the change in the reading? So we just 2 volts minus 0 volts equals 2 volts. The change is going to be 2 volts. Okay. Now you can actually see the same thing here. So when this is R, it will be 0. Okay, because you have all four the same resistors. But when this is 5R, you'll get something like R, R, 5R, and R. So same thing, you're actually going to get 6 volts here and 0 volts here. So on top, 6 volts, below 6 volts because it's going to be parallel. And again, here will be 3 volts. so that the potential difference is 3 volts, 3 volts. Here the potential difference is 5 volts or 1 volts, exactly the same. Okay, and when you put a voltmeter here, you'll measure 2 volts. Okay, the final potential difference is 2 volts. So from 0 to 2 volts, the change is going to be 2 volts.